Hi everyone, today in this video we will look at PED, price elasticity of demand, how it changes along a demand curve. So there is a misconception that PED is always the same in a demand curve. So just based on the gradient, whether it's steep or whether it's fairly flat, you would say it's inelastic or elastic. What this theory shows is that the PED will change along a demand curve, even if it's relatively inelastic or relatively elastic. So just for simplicity, I'm just going to start with this kind of neutral-ish demand curve, like a very kind of in between sloped demand curve. And I'm just going to prove to you that the PED changes. So you can see here that the PED is changing from minus infinity, going from here, and it's all the way falling all the way to minus 0.3. And actually, the closer that you get to here, it's going to get closer and closer and closer to 0. The closer you get to this point, it's going to be closer to minus 1 as well. Okay, so this is actually, I have to explain this in a mathematical way. I'm going to not go full maths. Well, I mean, I'll try and use like GCSE maths, looking at the basic percentage changes. We're going to have like a guided approach, but towards the end of the video, I will show you a more advanced approach, which might suit maybe more of the A-level maths people. Then we're going to look at how this is going to influence the total revenue curve that a demand curve that's downward sloping will have. So this is not something necessarily that you will have to learn too much in year 12, but this understanding will become useful to you by the time year 13 comes around, that your total revenue curve looks like this, actually because the PED is constantly changing along the demand curve. So bear with me, this will actually be maybe a slightly longer video. I know it's not for everyone, but in case you do have questions, here hopefully will be the answers. Okay, so just by looking at if we start from this point, point A, and we work out what happens to the percentage changes in price and quantity as we go from A to B, let's have a look. So we're going in price from 8 to 6, we're decreasing the price by 25%. Remember, to work out the percentage change in price, you do the new price, which is 6, minus the old price, which is 8, and you divide it by the old price, then times it by 100. In other words, the price has fallen by minus 2. The original was 8, then we multiply that by 100. Overall, this gives us a 25% decline in the price. That's what I have written down there. Notice that this percentage change is constantly changing. So if I go from 6 to 4, this looked like a C to me in my head. This is now a 33% decline. So it's changed, right? Even though it's still 2 units decreasing. And this is now a 50% decline. And then this is now a 100% decline. So I've got all of these kind of written down there. And again, if you go through the maths, in fact, hey, let's go through it one more time. For 6 to 4, so from B to C, we are changing from 6, we are now at 4. We divide by the original, which is 6, times by 100. This is a 33% decline. So the conclusion that we can get from this is that in a downward sloping demand curve, I might mute myself and come back just to save you some time, 1 second. Okay, so here I have some text. So I know it's a little difficult today, but okay. So what we've concluded is, as you go from point A to point B, the percentage change in price is 25% in absolute terms, but from B to C, it's now become higher to minus 33% in absolute terms. So put this the wrong way around. So what you can see here in a downward sloping demand curve, price falls from going from left to right on the demand curve. This causes the percentage change in price to increase, going up from 25 to 33% in absolute terms. So I'm ignoring the negative. And I'm proving that to you here. What's going on is I'm doing the same change each time. I'm decreasing the price by 2. But because my original value was 8, but now it's 6, then it's going to be 4. So because my original value is constantly getting smaller, then if you take the same value divided by something smaller, your value actually increases. So sort of what's going on is that you have the same change in price, but because your original number is getting smaller and smaller, that same change in price is going to feel more significant. So it's going to result into a much larger percentage change in price. Now that we've understood what happens to the price, let's look at the quantity. I'm just going to rub these out, so pause and take some notes if you need to. I just don't want to crowd this too much. I could use a rubber, but I think I had some things written under there too that I kind of want to get back to possibly. Right, so let's do the same thing. So in this case, we're changing the quantity from 0 to 1. This is going to be an infinity percent increase. Some people think it's 100%, but no, it's infinity. You're changing the quantity by 1, you're dividing it by 0. If you type this into your calculator, you'll get a math error. Because it's impossible to divide by 0, the number will just get so big that you can't display it. So this is infinity. Now from 1 to 2, the change is 1, but your original is now a larger number. Your original is now 1, which results in a percentage change of 100%. And then from 2 to 3, again, your change is still 1, but your original number is now a bigger number. It's now 2. Times this by 100, and you get a 50% increase. From 3 to 4, the percentage change in the quantity will now be 33%. And you can see that's what I've written here in this diagram. Percentage change infinity, 100%, 50%, 33%. And we can just use the same logic that we learned with the percentage change in price. What's happening to the percentage change in quantity is that we are taking our new quantity, we're dividing it, we're minusing our old one, and then we're dividing it by the old value. But notice in this diagram, we're always increasing the quantity by the same amount, just to kind of make this kind of fair and comparable. So we're always changing by the same at the top level. And then we are continually dividing each time as we go along the demand curve downwards by a bigger and bigger and bigger original quantity. So when you take a value and divide it by something that increasingly gets bigger, this is going to get smaller. This percentage change in quantity will get smaller. And that's what we learned here. We went from infinity, which is a massive number, to 100, to 50, to 33. So that kind of confirms to you that the percentage change in price, in summary, your percentage change in price is constantly getting bigger in absolute terms, going downwards along the demand curve, whereas your percentage change in quantity is constantly getting smaller as you go down the demand curve. Putting these things all together, we go back to what a PED equation is. The way I like to think of it is whatever said first goes on the bottom. So we do the percentage change in price divided by your percentage change in quantity. This percentage change in quantity is always getting smaller. This percentage change in price is always getting larger. So we would expect the PED value to always get smaller and smaller and smaller and get very, very, very close to 0 as you go along the demand curve. So it's going to get progressively smaller. And you can see that's the case here with the numbers that we just found. The PED is going from an extremely large number, in fact, infinity, because you had a percentage change in quantity by infinity. And it gets smaller. It gets to minus 3.3, minus 1, minus 0.3. And it's, as you get closer and closer and closer to E, and you make these changes smaller and smaller, it's going to get closer and closer to 0. Just note that this is, there's massive gaps in between A and B, B and C, and so on. In the real world, you wouldn't use such like big jumps. So you're going to see a more granular decrease, and you will see the PED equal minus 1, like really getting really close to C. But here it looks like it's going all the way to D. That's just because I'm taking these really big jumps. So I wouldn't look at these values like too precisely, because, well, the model isn't super precise right now. But anyway, that proves to you that the PED is always falling. Now I'm going to go through the more mathematical approach. You can skip the video in 2 minutes or so if that doesn't interest you. And then be sure to return for the total revenue. I think while that might not be super useful to you in year 12, it might be useful to you by the time year 13 comes around. So just bear with me a sec. I'm going to disappear, make some notes, and then I'll show you the maths behind this in more detail. Okay, let's go through the maths to understand this in a more formulaic way instead of the point-by-point method that I was illustrating to you. So here I have the PED equation as the percentage change in quantity demanded divided by the percentage change in price. Now we can actually plug in the percentage change in quantity as Q2 minus Q1 divided by Q1. And we can plug in the percentage change in price as P2 minus P1 divided by P1. And obviously these things are still being divided by each other. So like this line represents this one. Okay, so we have this kind of ugly, really big fraction here, and we can simplify that down. So I'm dividing by all of this. So what I can do is I'm dividing by this fraction, so I can just flip it. I think there's some math rule with that you might have learned at GCSE, which I won't go through. But anyway, that's how I get to multiplying by the inverse of that. The rest of it is the same. So like this, this is the same. Okay, and then when we get here, we can just separate it into a way that's like more visually friendly for you or more useful to you. So I'm still multiplying by these, and then I'm also then multiplying by that. I think you don't have to do this step, but for me, it's like nice to see it in that way. And then that can help me better understand kind of what's going on. So this time here on the right, Q2 minus Q1 divided by P2 minus P1. This is the change that we were talking about. So like, for example, if you're going from A to B, you are going from 8 to 6. So Q2 is 6. And this is that. So that's the minus 2 bit that we were talking about. And our price is changing from 0 to 1. So P2 is 1, this is 0. So we are like dividing by the 1. So basically this bit here just tells you the absolute change in quantity and the absolute change in the price. In other words, this is we're dividing by each of them. So this is actually our gradient. We can think of it like sort of like that. So PED is related to your gradient, but it's not just your gradient. It also has this other term here, which is the price ratio. And essentially that's what's going to help us explain what is happening. So this gradient doesn't help us explain why the PED changes. The gradient is always the same. You can see here, we're always changing price in this case by -2, and we're always increasing quantity by 1. So this guy is always minus a half. Okay, but the PED does change. So why is that? So it's because P1 divided by Q1 is constantly changing. This ratio always changes. Take, for example, at point A, the P1 is 8 and Q1 is 0. So this is like massive. But then by the time, let's say we get to D, the price is now 2 and the quantity is now 3. So this is just 2/3, 0.67. Anyway, the price ratio is essentially as you go along the demand curve gets smaller. That's it. So PED is basically decreasing as your price ratio, price to quantity ratio, is constantly decreasing. So I don't know if that helps some of you. Maybe it does, maybe it doesn't. I think that's kind of enough for that, but that will show you why the PED constantly changes as well. Right, back to the next important part, which is the relationship between all these changing PEDs and total revenue. I'm going to pause just 1 second to make some space for that. Okay, so I've added a couple notes and I've also summarized what we said here. So what we concluded from the prior work is that the demand curve has changing PED and it goes from super elastic, our example went to infinity, to elastic, to unitary, inelastic, and super inelastic. So it's constantly changing and the elasticity trends towards 0 as you go along the demand curve. So it becomes super inelastic. Right, you will have learned in year 12 that when the price falls, it can have different effects on revenue depending on the elasticity. That's because your quantity can respond strongly or it can respond hardly anything, so your revenue doesn't change much. So let's talk about the super elastic case here in the corner here. In this super elastic case, if I drop the price by, let's say, 10%, my quantity is going to increase by a lot more, 100%. In that case, my revenue is going to go up, but it won't just go up, it's going to super go up. So it's going to increase really, really, really quickly. So that's going to be my first attempt at drawing this total revenue graph. When I'm in this super kind of elastic region, I want to draw a really, really fast sort of increase in total revenue. But then as it becomes less elastic, it's not going to go up as quickly as it did before. Price is still falling, so price is still falling, revenue is still going up because it's still elastic, quantity is still responding by a lot, but not as much as before. So maybe before, while I was like on this trend, now it's going to kind of go down. Sorry, it won't go down, it's going to increase slower if I get my words kind of right. So you would expect the revenue to continue to increase, but it's going to increase slower. And it's always constantly becoming less elastic, right? So this increase is going to be like even less. When it's unitary elastic, if I'm changing the price, decreasing it by 10%, my quantity is increasing by 10% and my revenue is stagnant. So we are not going to expect anything happening to total revenue over there. That's just a tiny little moment, right? So it's not really going to be like a line. We're just going to pass through that point. Then it's going to become inelastic when, if the price falls, the revenue is going to go down. Remember, we're selling very similar levels of quantity, but we are dropping the price, so we are going to be worse off here with our revenue. And as it becomes super inelastic, the quantity is hardly changing, like at all. But your revenue will fall quite aggressively in that case. So this kind of summarizes the shape that if I drew it better, that we would expect, given the changing elasticity of the demand curve and total revenue. I think I managed, no, I didn't. I tried to draw a better total revenue curve here, but you see, kind of messed up with that, but try your best to draw it symmetrical and try your best for like the unitary elastic bit to correspond there to that maximum. And it should keep going until the end of your demand curve, and it should start where your demand curve starts, and it's nice and symmetrical. Okay, just for like an extension, if you are a year 13 student watching this and you have come across MR curves, you know that an MR curve shows the change in revenue, and the change in revenue is 0 right here at the top. So that kind of also explains your MR curve, and actually keeps going down like that, but maybe that's not worth to discuss too much in this video today. Anyway, hopefully that tells you the relationship between demand, PED, and total revenue, and even MR. Thank you very much for watching. This was an exciting video. Let me know your feedback, and if you have any questions, I'm happy to take a look at them. Thank you very much for watching.